Hello everybody, today we will be learning about bases. In my previous presentation, we learned about the definition of acids, properties that acids display, and the three general reactions of acid. However, you may not be that familiar about bases. So, what are bases? Basically, bases are metal oxides or metal hydroxides. Some examples that I can quickly think of are calcium oxide, sodium hydroxide, zinc oxide, copper 2 oxide, lithium hydroxide, magnesium hydroxide, and potassium hydroxide. These are all considered bases as they are either metal oxide or metal hydroxide. Recall that we have already learned that bases react with acids to form salt and water. Hence, one common application of the base magnesium hydroxide is to neutralize the excess acid in our stomach when we suffer from gastric pain. Magnesium hydroxide is commonly known as milk of magnesia. Bases can also be found in cosmetics because some oxides, such as iron oxides, zinc oxide, and titanium dioxide, are colored. Sodium hydroxide is found in soaps and washing detergents. Aqueous ammonia is used commonly in household cleaners. So now, what is the difference between base and alkaline then? Most bases are insoluble. They are not able to dissolve in water. However, there are some bases that are soluble in water and we call a soluble base an alkaline. Let me show you again using a Venn diagram. In this Venn diagram, I have some examples of bases, of which two of the bases are soluble in water. Do you know which two are soluble? The answer is sodium hydroxide NaOH and potassium hydroxide KOH. So, we can specifically label these two bases as alkalines. In our syllabus, we will need to memorize the three examples of alkalines and their chemical formula. These three are sodium hydroxide, potassium hydroxide, and aqueous ammonia. They are commonly called SPA for short, S for sodium, P for potassium, and A for ammonia. So, while acids form hydrogen ions, alkalines form hydroxide ions when dissolved in water. As you can see in the diagram, sodium hydroxide dissociate to form sodium ions and hydroxide ions. It is the hydroxide ions that give alkaline its alkaline properties. Some properties of alkaline is that it is a good conductor of electricity in aqueous state. It is corrosive when it is concentrated. The pH of alkaline is more than 7 and it turns red litmus paper blue. And it is at this point in time that I would like to clarify that insoluble bases do not change the color of indicators. This is because they are insoluble and cannot dissociate to form hydroxide ions. Let's take a look at the chemical properties of alkaline. This is a new reaction that we have not learned before. Alkalines react with ammonium salt to give salt, ammonia gas, and water. So, let's take a look at one example. Can you take some time to deduce what are the products formed when sodium hydroxide reacts with ammonium nitrate? So, did you manage to get sodium nitrate, ammonia gas, and water? By the way, ammonia gas is a pungent gas that can be identified using a red litmus paper. Ammonia gas will turn the moist red litmus paper blue. Second reaction is the precipitation reaction. Alkaline will form precipitates with certain cations. You need not learn about precipitation right now, but it is pretty simple. A precipitation reaction involves the exchange of ions. Let's take a look at one example first. So, what will be the products for the reaction of sodium hydroxide and lead 2 nitrate? Let's exchange the pairing of these ions. And we will get sodium nitrate and lead 2 hydroxide. Are you getting it? Let's do another example. We have sodium hydroxide and iron 2 chloride now. So what will be the products? Did you manage to get sodium chloride and iron 2 hydroxide? We have come to an end for the PowerPoint presentation. Hopefully, you have understood the definition of bases, able to differentiate the term bases and alkalines, and also know the two reactions of alkalines. Thank you for listening. Bye!